Thank you for joining Once Changing the World, India's first future tech meets sustainability podcast. And today I'm delighted and honored to have with me Mr. Siddhant Bhambri, who is a PhD student under the supervision of Dr. Subbarao Kambapati in UCAN lab at the School of Computing in AI, Arizona State University. His goal is to advance the field of human-aware artificial intelligence, and his primary research interest lies in developing embodied AI agents using reinforcement and preference-based learning, and also large language models. So, Siddhant, really appreciate you taking time and being part of the podcast. Large language models, I think it will be great if you could start with explaining the fundamental process of building a large language model, and maybe also kind of explain the key components involved in its architecture.
Right. So getting things started first, thank you so much, Adi, for having me. It's an honor as well. And thank you for the kind introduction. Getting started with large language models, well, that has become the buzz these days with not just, I think, people in computer science, but definitely people far beyond that in several disciplines. So the way I will describe it may be an oversimplification, but I'll try my best, at least such that it is easier to get a grasp of what essentially is happening under the hood, to the best of my knowledge. So there are three primary stages, at least, that we got a glimpse of when ChatGPT from OpenAI had come out, maybe around 2 years back from now. So the first is, underlying all this is an architecture or a neural network at the very least, called the transformer network. And I won't go into the details of it, but the idea is that the transformer network in the natural language processing discipline has been remarkable to capture language dependencies. For example, in a sentence, which words are connected in what particular manner, which with other words in that sentence. And it was able to perform extremely well across a bunch of tasks. So the primary objective of training a transformer network would be that it learns the probability of what is the most likely next word to generate when you are given some context. And this context could be the sentence up till a certain point, maybe a question that was asked before it. So we are essentially trying to learn these conditional probability tables that conditioned on whatever context you have so far, what is the most next likely token, as the technical terminology goes, would be. The second part in this pipeline would be supervised fine-tuning. So supervised first, that would mean that we have access to a bunch of data where we know for every question what the right answer is, and fine-tuning because this is a model that we have trained and we want it to perform well on some specific tasks at this point. And this could be a variety of tasks. So that is the next step that can be done over this transformer model. So in layman's term, we already have a model that learned how to say something in English. I'm just taking an example of English language here. Then by supervised fine-tuning, we have something that it is able to give some right answers in English for certain specific questions. So this is the point that we have reached. Now, the third part is the popular term of reinforcement learning from human feedback, or abbreviated as RLHF, which OpenAI hired a bunch of people in Africa, as far as I remember correctly, to give some annotations to the responses that the model was producing. So essentially what is happening is we know that the supervised fine-tuned model knows how to answer, I'm assuming, and that's not a generalizable statement, but it knows how to answer some specific questions. And there may be multiple ways to answer that. For example, I can write a mail to my advisor in a certain friendly tone, or it can be a professional tone. But given the context that this is to a professional setting, I may prefer to write a professional tone, use a professional tone essentially. So, and there are several other examples that we can think of. These humans are specifically rewarding these responses which are more preferred than the other. And that is what the human feedback essentially consists of, like picking one response over the other. And we can have many people annotating the same set of responses as well, just to get an average across the two. So that is what the third stage would achieve, that first you answered what to say, second you answered what are the right things to say, and third is in what way do you want to say it. So that specifically at least sums up the basic pipeline, I would say.
Right. So that's really appreciate you like giving like a brief understanding of what a large language model is and what goes behind the hood to kind of build a large language model. Right from the transformer paper, attention is all you need, to, and but it is still now considered like a next token predictor, because like a data in, data out model. And then you've mentioned about supervised fine tuning, because the data, it learns from the data. The more the data can you feed in, it understands better. And then you also spoke about reinforcement learning, RLHF, with human feedback. And that's when you have the human in the loop, so that you kind of correct things, rather than having the model go haywire. And obviously there's many other things, like rags, and also like fine tuning and inference tuning and stuff like that. But like this is basically like the brief of overview of building these large language model. Now you've also been researching on understanding the advantages and the limitations of a foundation model. Will you be able to share your insights on both? I mean, the advantages of these LLMs. What are they able to do? What are you surprised from by these like statistical models, and what do you think are its limitations?
That's a great question. And the reason I find it very, very interesting is because there are parts which are really impressive. It can generate exceptionally written language. At least I'm talking about English language in this case. So it's very easy for us humans to get deceived that it knows what it's doing. And this is just something very inherent, I believe. And this has come up with a lot of discussions I've had, even during my PhD with my colleagues and my supervisor a lot, that we as humans prefer syntax over semantics. We will go no matter how good looking a person is, how smartly dressed they would be. We will form a very positive impression as the first impression in our mind. We wouldn't even try to think a step beyond that as to what semantics in that would be, how knowledgeable maybe that person is. Like the classic saying goes, never judge a book by its cover, for example. So we are easily deceived by it, which is why I think there is a great divide even till now in the literature, since it's a really recent model, although in the last 2 years, the field has developed very aggressively for artificial intelligence or AI in general. However, coming back to the point, there are at the surface level very impressive things that it can do. For example, tasks like creative writing, rephrasing, summarizing, some natural language tasks. I'm just coming up with examples on top of my head. Generating code, for example, right now is an extremely easy task, it seems like. However, it's hard to define what the bounds of the kind of code we can write, but it's doing reasonably well on the problems that humans are expected to solve, for example, which are reasoning problems. But the funny thing is that we are not able to objectively define what reasoning is. Every task, every thought process can be defined as reasoning. So that is a subjective term and has been loosely used in the context of language models and their abilities. And we talk about abilities, which is like a personification to begin with, as if there are emerging abilities. And these are terms that I'm sure people would have heard around large language models, that they are able to think, they are able to solve tasks. So that level of personification is at an extreme. Even in scientific papers and literature, and it's not just layman terminology. So these do create biases in people's minds, and which is why it is really, really, I think I'm trying to motivate as to why it is important to get rid of these biases as much as we can and understand where do these models actually fail. To, like, at the end of the day, we would want any technology to come to a point where they can make our life simpler. And yes, they have been able to do so in certain cases where we know they are really good at, and there are no safety constraints or not many safety constraints to worry about, at least not life critical constraints, such as creative writing. I mean, a bunch of big tech companies have come up and incorporated these into their products such that we can use them on a daily basis. And there have been problems, there have been false positives where there have been a lot of issues that these models generated because they are trained on human data, and humans don't always write clean data on the internet. So a lot of it depends on what they are trained on, which is also like a black box to this point, unless in the open source literature where we still are able to see at least the set of data sets that are there. They go through pre-processing, they are clean and whatnot. So it's still easier to understand, but especially behind the big models, behind OpenAI models, for example, even till today, we have no idea as to what is going under, to be transparently clear at least. So coming back to my own research, at least I my research direction in my PhD focuses on understanding the different roles language models can play in the human in the loop decision making pipelines. So my prior interest stems from reinforcement learning or decision making algorithms in general, and which also includes classical planning, search algorithms as well. And I have looked at certain problems in reinforcement learning where we can learn from human feedback, but for a different set of problems, not particularly say natural language problems right now. But pivoting towards large language models, the way I understand is human effort is extremely costly. And this can be domain experts who have extreme complete idea of what they want to do, what they expect the models to do. And this could be layman users as well who want to, maybe we want to get some feedback from them. Maybe we want them to give some suggestions as to how they would want the generated output of a model to look like. Which is something like a preference at the very least. So what are the roles that these language models can play on behalf of humans? Essentially, trying to reduce the effort or maybe the number of times I'm going to ask a particular user who I already know of, like I have built a model for them and categorized a set of users under some specific attributes. Can I use these models to get some commonsensical knowledge, get some feedback which may not be very user specific, may not be very task specific at least, but still be very useful to the downstream task that the user is going to interact with. And doing so, I do realize at least some of the advantages there that I have seen is there is a certain level of abstraction where these models perform really good. And now in terms of abstraction, I mean that imagine there is a hierarchy and the problem is at the very ground truth level that I'm trying to solve with say, ideally a computer science algorithm. And I would want actual users to give me some information to solve that task. But let's try to convert and simplify this problem to a level in terms of natural language or maybe even images now at this point, because we have vision language models as well, where I can get sufficient information that can help me down the hierarchy essentially. So this abstraction is really allowing me to bridge the gap between what I would have wanted exactly for my problem and also what I can expect these models to reasonably give me. So in my very brief experience during my 4 years of PhD and the limited time I've spent working with these models, my understanding is that there is a trade-off, definitely, when we are trying to use these models. The approach has to be very cautious. We have to start approaching them without giving them a benefit out. And that's when at least we'll realize I'm happy to be surprised if they are good at something rather than starting with the thought that, oh, they are going to be good. And let's see where I fail, which I don't think is a reasonable approach if we are trying to build products for end users.
You mentioned through the course of the conversation that these models are black box. People are still working on interpretability, explainable AI, but then we don't really understand what's going on under the hood. There have been people such as there was a scientist from Google who claimed that the model is sentient. And there are people like Ilya and many other who have also tried to kind of push the idea that these statistical models, the data and basically data in, data out, you pour in data, you get only data out. It's nowhere close to how our brain works. But there are leaders in the space such as Ilya and many others, I think, who have spoke about these models, large language models, having these possibly doing something what even maybe they cannot like truly understand. And there have been papers, papers which has been written about, you mentioned about these emergent properties of these large language models. There's also been papers which has debated and said, it's a mirage and things like that. Then recently Anthropic dropped a paper which said that their AI model is faking alignment. You have been the co-author of Theory of Mind, Abilities of Large Language Models in Human Robot Interaction and Illusion. That's what the paper is titled. Will be great if you can give your insight on this theory of mind as well as thoughts on what people are talking about, this emergent capabilities and faking alignment, a large language model faking alignment.
Right. So it's interesting, as I said, like again, we are going back to the point that this personification makes the hype worthwhile going into and delving into, absolutely. And I believe it's not really happening for the first time. For example, things we don't understand, we always want to give them a name as humanity. And sometimes we call it a myth, sometimes we call it faith. And things we do understand, we included as part of science. I mean, that's just observed, I believe. So I think we are at a stage where, yes, we don't completely know. And it's definitely impossible for me to speak on why somebody claims as to why they may be sentient. They're exceptionally smarter people than me, and I'm sure they might have a reason. But the idea for people to understand what really happening is through transparency. And if there are claims that need to be made regarding what these models are, and more importantly, why they are supposedly thinking, or why they are able to fake certain attributes which we thought they are at the first place able to do, I think um, publication and research and open-ended conversations are really, really crucial to that aspect. And that's how science has always progressed. I mean, not just for this particular field, but for any field. But one of the reasons, and I think this is a point that has been brought up by several people talking about this topic, is the mention of Goodhart's law. That a measure tends to cease as a measure once it becomes a target, essentially. So these bunch of domains that we are constantly having a leaderboard for with every model that comes out, we are basically saying, is that really AGI? Are those benchmarks the true essence of what AGI is? AGI is, first of all, artificial general intelligence, which as a term is not objectively defined again. But good to throw out terms like this, especially when everybody wants to hear that, right? And that's pretty much what the bandwagon has become all about. And sadly, I mean, from a very like a very simple student's perspective, I feel bad at times that these terms being loosely used even in research publications, where the idea is just to be extremely objective about what your assumptions are, what your experimental settings are, your hypothesis is, and then you either prove it or refute it. But definitely these terms throw us off the way. So there are ways in which people, I would say, would want to argue as to why these models are able to have certain abilities. But then again, the point of transparency comes into the picture. So that's that, at least. Coming back and linking this conversation to this paper that I co-authored along with one of my colleagues who is now working as a research scientist in Google and my advisor at ASU. We talked about theory of mind. Now, theory of mind, I remember from my first year, is a concept that I came across and I was very intrigued by, because that's something we do all the time. It's essentially trying to model the other person. Like at this point in our conversation, I would want to understand that maybe you and the rest of the audience who's listening to our conversation, what do they want to hear? What do they want to know? What are the terms that they may be able to connect with that will help them understand this conversation? And this happens at pretty much throughout the day with whosoever we interact with, right? We want to understand and talk according to that person or express our thoughts in that way. So we are able to have this modeling ability of the other person. And there's a classical test called the Sally-Ann test, which talks about theory of mind. And I'll just briefly go through the test as much as I remember. That there are two girls and you are an observer, and these two girls are in a room a room that you can see. And Sally puts a ball in a box, and Anne leaves the room. And Sally takes the ball out of that box and puts it, say, in a different box, for example. So if Anne comes back into the room, which box is she going to look into? And children under a certain age, I believe it's 3 years or so, are unable to understand that you now have to think from Anne's perspective, but not Sally's perspective, which is the ground truth. But we would be able to do that. So essentially, we are able to model this another person's perspective of a problem that they are observing, and we know the truth behind it as well, which are two different things. So our quest was that in certain behaviors that agents exhibit, for example, if the robot is going from, say, one corner to another in a garden, where it can go along the sides of the garden, which is a paved path, or along the grass, which would damage the grass as well as maybe hamper the robot's wheels, for example. A human would say that the robot going along the diagonal through the grass is not an explainable behavior, because it's not following, it's maybe going through an optimal route, which is the shortest distance, but it's not explainable because I would want it to go through the paved path. Can a language model give the same answer that a human would have given? Because at times what the tests reveal that we put up data on the internet that may be right, may be wrong, but we do not put the reasoning thoughts behind that, which you can think of as like a derivational trace. That if a fact A is true and if a fact B is true, and if A implies B, all that we are putting on the internet is A implies B. Do we know how A implies B, or do we know how did we reach from, say, this initial point to the final point, which might be the goal of the solution of the problem? And due to that limited data, one possible question we wanted to test is that this is a reasoning problem in itself. To be able to understand, okay, that the human is going to observe in this way, that they are going to reason in this process. And the question is for me to reason on behalf of the user. Can I give the same answer or not? A language model is not supposed to do this, but the question is, can it? And which is why we had a user study as well, where we wanted to see, can lay users do this as well? So from a spectrum of lay users to domain experts who would know exactly what the right answers are, where do these language models lie on this spectrum, at least for this very specific task? So the interesting thing is, and their performance closely aligns with, at least maybe by some prompt engineering or something, some tricks here and there, their performance comes reasonably close to what lay users would do. It's not perfect, it's nowhere near domain experts, but it comes reasonably close. But the question is how robust and brittle they are. And that is where I would point out that we need to understand their limitations. Where do we draw the line? Can we rely on them even if we are asking some adversarial questions? For example, what if I just put the exact same question and say that the human has closed their eyes? Can it reason that entire answer just gets nullified by this one small statement because now the human can't see? So it should come up with an answer that probably the human can't even decide what the right answer is. Is the robot explainable, acting in an explainable way or not? But they've completely failed. Like the performances that we observe completely drop down to zero for multiple cases across multiple experimental settings. So the idea is that if your test case is like a very vanilla setting where you may expect, say, for example, lay users to be able to reasonably do so, and you don't have a lot of safety constraints along with it, yes, maybe they are reasonably well in understanding and to some extent. But adversarial attacks made on them, and there are a bunch of jailbreak tests which people are still doing even with the newer models and so on. And we continue to keep finding issues with them when these things exist. So the idea is, out in the real world, if these models are deployed, these are important considerations naturally. Adversarial attacks became a huge area of interest at its time when back in, I think, in 2016, one of the famous researchers, Ian Goodfellow, talked about it and one of the revolutionary papers of the time. But then those cyber attacks or adversarial attacks in different aspects have been studied. Their solutions have been studied. And I believe the same approach is really, really important to understand the limitations of these models so that at least we can try improving them, which involves not just understanding them, but also understanding their failure points. And this work was probably one small effort in that direction.
Right. So, Siddhant, I'm just going to pick this, because you mentioned that, what we need to do is have open-ended conversations. But I'm not so very sure whether, the education institutes or society in general are open to having an open-ended conversation, when we don't completely understand it, because yes, it's plain to see that these are statistical models, because you throw in data and it throws out data, and it shouldn't be doing the things that it is doing. But the point about which you mentioned, being transparent and open into conversation, this happened back in 1930s, I'm assuming, when we had the first understanding of quantum physics. There was various interpretation of it. There was this Copenhagen interpretation which says that observer brings about reality. And then there was a Govt interpretation about the quantum mechanics of the many worlds, that every time the observer sees something, it branches out in a different reality altogether. But then we kind of completely whatever the cutting edge of what understanding at that point of time, all the the professors and all, they were said, okay, look at the other side, rather than kind of probing this. So I'm not so very sure whether as a human race, I mean, if there is something weird going on, are we like even open to having these open-ended conversations? Because what the natural reaction is, like, let's push these guys to a corner because these seems like extremely weird. And I mean, why would like a data in data out model show any of these emerging properties of fake alignment? So I'm not so very sure about that, whether open-ended conversations is like the correct approach, because I don't think the academic institutions want something which is goes into the woo-woo track, because it just goes into the woo-woo track that these data and data out models can show something of these emergent properties. You are one of the co-authors of the paper which says LLM can't plan but can help planning in LLM modular frameworks. There was something else also, robust planning with LLM modular frameworks, case study in travel planning. You mentioned about the limitations of these large language models. It can't do this, it can't do that. Can you explain LLM modular frameworks and its role in augmenting planning in these models?
Right. So, first point regarding if transparency is the way to go or not. Yes, I'm sure it's very clear that it's not the first time in science where there have been several theories about a certain topic that people are currently trying to understand. But I think this constant back and forth every time has allowed us to reconcile to a theory by several experiments, several reproducible experiments, at least by different people over different periods of time, just to validate that those certain theories are correct and certain theories are not. And I think maybe the time frame at which we look at and discuss this topic would really, really be important. But clearly, right now, the pace is too fast for many people to catch up to in terms of understanding or in terms of how reproducible certain results would be and so on. But in general, I believe this process is really important to have people on both sides, and such that we can have like reasonable arguments, technical arguments. And it is good. I think one of the most important things I am still learning, I've learned and I'm continuously learning, is to be happy to be argued with and get to a point where I get to know that, okay, my understanding was wrong. And that, to be honest, is one of the best feelings I have experienced multiple times in my PhD as well.
True, completely.
It's a really humbling experience. And I think people who are trying to develop these models on both sides and even trying to understand or explain the workings of these should have a similar approach, at least to that matter, so that we get to a point where we have a really good understanding of the uses and limitations of these models. Coming back to LLM modulo, which is a very interesting connection here, because since we have been talking about limitations and how brittle these models are, and one of the works that has been spearheaded by my advisor, and he has given several talks on the framework as well, because it's a very fundamental concept behind LLM modulo, that you try something, you have something that gives you feedback or criticism, and then you try again. And this is what a student in a school would do, right? Attempt a question, the teacher would give some feedback. May not be giving the right answer away, but you'll give some feedback that may help the student to try again and generate another answer. That's essentially a one-line simplification of LLM modulo. We want to have these modules called verifiers, which are basically checking if the output generated by the language model is valid or not. It may be the correct one, it may not be the optimal one, but at least it's not an invalid output. For example, there are only certain specific answers for a set of questions that you may want to come up with. If I'm talking about what are the different digits that may exist, you'll only say from 0 to 9. You don't want to give any other random token as an answer, essentially. So do the generated outputs fall within a certain range of answers that are acceptable for a problem, essentially? And then can you give some additional feedback that can improvise that answer? Something like, maybe as people have tried something as simple as try again. A lot of robotic models which are being learned, and if they execute an action or come up with an action in terms of, say, the XYZ coordinates of the robotic arm, the feedback that goes into them is as simple as try again. And at times it may work. It has no rhyme and rhythm given to what the problem is, what the current action of the robot is or the agent is. But things like these can work. And there are several anthropomorphizations like this, which people have keep trying in terms of prompt engineering with and without these verifiers. The essential idea of having a verifier is that you have some level of soundness guarantees as to within this framework where I have this LLM or language model augmented along with a verifier, which can have several back and forth output generations and feedback criticism cycles. And then maybe after some threshold of these cycles, a possible answer can come out. Once maybe my verifier thinks that this answer possibly is the correct answer. Or at least based on the feedback that is giving, then maybe there is always a chance, there is guaranteed to be performance which is better than just having that language model solve that problem. Because at least you removed some sources of error by having these cycles in this loop. Essentially, there was another work, one of the recent works that I was part of, where I was initially talking in this conversation about the different abstractions. So we tried experimenting even there that can we have these verifiers to augment LLM outputs or to check LLM outputs at a different level of abstraction as well. Because understanding one point about these verifiers is that who is building these? It's us humans who are building this. It's the domain experts. For something as simple as Python language, as a programming language, it's the compilers that are checking. So compiler is your verifier in that case, essentially. And there are several works that have talked about LLMs generating code where the code gets checked by these verifiers, and that's simply what it is. Maybe the compiler gives you that, okay, this is the error in the code. You may not be able to correct the logic in the code, but you may at least be able to correct the syntax errors in the code. So to some extent, you are reducing the sources of errors and trying to come up with a better performance, which is definitely going to be better than just an LLM. So having these tools essentially in this pipeline can surely help in that aspect.
Right. Interesting. So that I wanted to get your thoughts on DeepSeek, because it's been in the news globally, and I'm sure you must have kind of tinkered around with the model, both V3 and the R1 reasoning model. Would you be able to kind of share, or if you have an understanding, if you kind of tinker around, like what's the backdoor innovations have they use for optimizing these models, both for training and inference, which has managed to, this model has managed to perform models such as Meta's Llama 3.1 and OpenAI's GPT 4.0. Yeah, so would be great if you could share your insights on what's happening over there. I mean, how come there are these OpenAI which spend billions of dollars, and here it's done 5.1 million. So I'm sure that's not the entire story. I mean, we get that, but what have they like such a small team managed to do? Because what I've been, at least, I mean, what we've been seeing globally is that even right now that's been happening. It's the US government with its AI diffusion policy and export control. They have kind of restricted couple of nations to have these state of the art chips. Nvidia has actually pretty much banned these AI chips to go to China. What have they done? I mean, it would be great if you could elaborate on that.
So I was listening to a recent podcast on Intrepid, which was hosting a bunch of technical people, including Richard Sutton, who is one of the greatest pioneers of reinforcement learning. And one of the persons in that podcast said this very interesting thing about how did DeepSeek achieve this? I think, and their perspective, I really resonated, I think, with their perspective that yes, as you rightly pointed out, that US is not giving them access to the best state-of-the-art GPUs, and they may not be able to get a lot of funding. I'm not sure how the financial logistics work out on the other side of the world. But the idea is, you gave engineers a constraint problem and they solved it pretty amazingly. And and that's a beautiful thing in itself. At least I feel that. Yes, there may be certain research innovations, but there are incredible engineering innovations that they were able to work around with limited resources, distributed computing, multiple parallel GPU trainings. And I'm sure there is a lot of other inputs that would have gone in what this model is able to achieve with such a limited training budget, for sure. But even in terms of, if you talk about the size of the model, or how the model has been trained, and there are definitely innovations and tricks that have been very, very useful. So I recently was tinkering around. I still am trying to make sense of now, because this is way more transparent than we ever had any access to any reasoning model per se. Because now what these reasoning traces that these models generate before giving out the final answer, at least we are able to look at, which changes the ball game completely, because till date we never had access to these. Even OpenAI's model, which is still doing exceptionally well on these benchmarks that we were earlier talking about, and I'm talking specifically about the O1 model, which was their reasoning model. It had some thinking tokens that people are being charged for, but we can't see what those tokens are, how many tokens are being generated. Maybe there's a calculation to count that, but still the content matters. Like, we are trying to understand how it supposedly thinks to get to an answer, and that is the whole point. Like, to be able to say if they are actually reasoning, and to me the reasoning would mean, are they following the algorithmic procedure of solving a problem for which we already know some algorithms for. So at least we can have like an apples to apples comparison. Or even if they're not using the same procedure, how are they still able to generate the correct answer? Maybe there are indirect ways that it is, from whatever data correlations or patterns it is learning, that it is able to reach the correct answer. So that is, I think, still an ongoing effort. I'm sure a bunch of people are looking at it. But one of the things I think that has caught the limelight and has become really, really hot as a topic is the reinforcement learning paradigm, when DeepSeek talked about as to how reinforcement learning training, the way they do it, and specifically using an algorithm called GRPO, which is Group Relative Policy Optimization, built on a very standard and very commonly used algorithm called PPO, which is Proximal Policy Optimization, and has been there in the reinforcement learning, conventional reinforcement learning as we know it, literature for a while now. So, and the way they do it is in the hopes of that they are trying to replace, I think in one of the models, they do completely get rid of supervised fine tuning, and they are trying to learn the correct answers, or through generating these intermediate steps, reaching till the last step, and these steps are essentially just words, like one word at a time. So if somebody asks me that what is 7 cross 3, all the model is doing is generating the next word in response to this query. And then the context becomes this query and the first word, then query and the second word, and so on. Once you get to the last point where maybe the answer was, and it said that the product of 7 and 3 is 21, you are essentially incentivized with a positive reward, which is a training signal for reinforcement learning at the very fundamental level. What DeepSeek is essentially able to do with this algorithm called GRPO is they are generating multiple outputs for the same response, and they are able to check which of these, and they are able to score each of these outputs. So given whichever outputs are being scored, some may be leading to correct answers, some may be leading to incorrect answers. I think that binary distinction is sufficient. You are scoring each of these outputs and then back propagating this training signal essentially. I think that's a very simple way of explaining at least where are they getting the signal of what the right method is to reach to the answer. But I think this reinforcement learning allows for this multi-hop decision making, which essentially in supervised fine-tuning may have been somewhat more complicated to, maybe there is definitely surely a way to do it using supervised fine-tuning techniques, but it may be costly or computationally way more expensive, because for every next word you would have to do the supervised fine-tuning step. And in reinforcement learning, you are able to look at this entire trace, which are these multiple steps, and then score the steps based on the final output. So it is still definitely not 100% clear, and not to me for sure right now, as to what is that golden piece that they were able to break. But it's surely worth looking into and investigating now that there is more understanding, or at least more legibility of what it's generating before giving the right answer. Because I think coming to the right answer is not really as important as how it is being reached.
Right. Siddhant, so I think what makes this exceptionally unique is not just their backdoor innovation, doing something frugally as well as, zagging when the world was zigging, because, so far I think the conversation or the narrative was that, to build these models, you need millions of dollars, data, compute, as well as unique algorithm. And here they are, completely finding like another paradigm altogether with GRPO. So I'm sure there are like these more possibly backdoor innovations which are still possibly open and then could be explored in the next few years, because I think with this the US government's AI policy, diffusion export control policy, eventually will possibly push the countries to kind of innovate, the ones who are vested in AI, because I think the more you push somebody in the corner, somebody, I mean, the more the chances that they'll find like ways to kind of, like maybe like a workaround of that. And I think that's very plain to see, China did that. And but India also, I mean, because US is kind of, divided the countries into three different groups of countries, like the allied countries, and India happens to be in the second bunch of countries, and then China, Russia, and the Iraq, Iran, and those they fall into the third countries. But I'm sure that this also pushes the countries to innovate, but also I feel that it's kind of sowed the seeds of possibly like a future war, because we've already created division, because I think these technology stack are so awesome, and it's always was supposed to be decentralized and open, but I think because our world runs in a very centralized manner, and we always run for profit at any cost, here we are, I mean, doing the same wrongs that we have done throughout history by giving like a centralized organization more power, when the world is completely changed. We live in a hyper connected world, today I think what's happening in a certain part of the world disrupts the entire world, and there was plain to see with China, the COVID kind of virus broke out over there, and people thought that, whoa, we somewhere else, it's not going to affect us. But here, I mean, the entire world got affected, and we had to completely shut down. So I yes, there is two things which I see from my perspective. That I think it's going to sport like a new wave of innovations, because there's going to be countries and organizations trying to find backdoors and see that and peer through these open source model, because OpenAI claims to be open, but it's completely closed. And then this, at least, I mean, even DeepSeek is not completely open, but at least you can understand things a little bit much better. So it gives the opportunity for people to kind of innovate. But the other side, which I think is scary, is that we've got into this AI dominance, AI race, where these nations want to kind of hold these technological advancements for their benefits, so that becomes like really, really scary. So I don't really know where the world would go go to with such a great moment in human history, where we have like a possibly like a self-learning tech stack, because we never had like a self-learning tech stack. 2025, it's supposed to be the year of agentic AI, because LLMs can, it's still called the next token predictor, but then it's these the ones who are vested in the space say that agentic AI would be able to do much more. It would be able to plan, it would be able to reason, it'll also be able to act on it and create these solutions. Will be great if you can kind of explain agentic AI a little bit more. What I mean, we don't have much agentic AI platforms yet. OpenAI has started something, but we don't really have. Will be great if you could also talk about this capability. And will be also nice if you could walk us through like the steps or process of building an agentic AI application.
Right. So I believe the first point that you brought up regarding the different impacts these technologies would have, not just at a very local level, but at a very global level, I think that's very much expected and natural. I think the ripple effect is always there for something as big as this, which has definitely made a splash in terms of technology and the kind of uses it does bring. And I think and I think this is a perfect example to talk about in context to the transparency that we were earlier discussing. That now look that a company with a lot of engineering constraints and with a lot of computational constraints were able to come up with something, and they open sourced it. And this has allowed people to understand a lot more than they were able to do before. And I think that's one small step towards that transparency. And I'm not denying the fact that money plays a very important role, or economy plays a very important role in terms of how research is driven across different parts of the world. That is definitely very true. The companies would not be able or would not want to completely open source their technologies or their agentic AI models as to how they are working at the like behind our backs. But I totally understand the practicality of it, but when it comes to understanding something, I think I'm trying to be conservative and have a very idealistic approach, at least to begin with. And yes, it's an iterative thing that you refine your approach based on what is possible to understand, what is not, but that rigor should not go away, essentially. So I think even with baby steps of whatever these models are bringing in front of us, in terms of, are the models open sourced? Do we know what data they are being trained in? At least gives us some insights, maybe at a smaller scale, of how the small models are behaving. And let's see how the scalability laws hold up. Let's see how the insights that we draw from the smaller models or from the smaller data sets and understandings that we get from them can apply to the bigger models that we have lesser idea about. Which would also include black box models, which are completely proprietary. Let's just say. So it is going to take time, but I think I think reiterating the previous point I had, that the approach is really, really important. It definitely creates some divide, at least I think, and I am no political expert, so I am not sure. At least I'm sure that there are several other factors taken into account when certain constraints are put in terms of technological advancements on other countries. For example, in this case, the case of GPUs, at least China was not given any access to H100 GPUs by NVIDIA. But that hasn't stopped innovation. That definitely, as you rightly said, that if somebody's cornered, they might just utilize that opportunity and come up with something better, and they proved it. And I think that is really commendable, giving them the due credit for it. So democratization of technology, I think, is an old topic. The technology keeps changing in that aspect, and which set of people have access to which technologies is always an ongoing debate. There are ethical concerns, there are safety concerns, and depending on what the technology is. I mean, we did have, for example, say CRISPR, which was the gene editing study that was carried out, which would have had several ethical concerns, and I'm sure there are continued debates on it. I'm not familiar with what the recent research is on it, but these are clearly technologies that can have impacts beyond what we think they may have, and especially for those which we are not fully sure of what they can achieve and what they cannot. So a more cautious and conservative approach is definitely better, at least in my viewpoint. And then at least we'll see where it goes. Coming back to the agentic AI discussion, I think, and that's one of the terms which, in my opinion, got a lot of popularity after Andrew Ng, the famous researcher who's also the creator of Coursera, gave a talk, I believe, talking about agentic AI or agentic LLMs in that case. The way I define agentic AI is at least very simple. I mean, the way agents is not a new term to AI. Agents was defined as long as in the original AI and an introduction to AI book by Stuart Russell and Peter Norvig, which is the classical Bible of, I would say, artificial intelligence. And that is where it was originally defined. In this context of LLMs, I think all we are trying to say is that these models are good at a bunch of tasks. So there's a breadth of tasks we can talk about, but they are shallow at what they can do. So they are shallow and broad, and I think this is a terminology I have stolen from my PhD supervisor. But it is really helpful to understand at least what they are capable of and what they are not. So how can we augment them or utilize them in such a way that they are useful for certain applications where we may want depth in one specific task or one specific problem? You can say, oh, let's just fine tune the model such that it can perform better on one specific task. But maybe those things are not enough. Fine tuning has its own limitations, of course. LLM modulo in this context is another great example, because I mean, to me, even LLM modulo is an agentic AI setup, because we have LLM augmented with a task specific verifier in this case, which is at least filtering out some sources of errors as we earlier talked about. And a lot of these companies, for example, say Google has Gemini, Microsoft has Copilot, we have Perplexity, we have OpenAI, which came up with, I think it's called Operator, which are essentially augmenting these LLMs with search engines such that they can understand the user queries, probably break that search query into several components, look it up, get the real information. And I think that's the way I understand, and it may not be the same way as it's happening behind the back. But they augmented the LLM with a search engine or a search tool, essentially. I think that in this loose definition of what agentic AI is, I think that qualifies for it surely. So the idea is that, and I think question is, why did they have to do it? Because LLM only knew about, I think in the beginning stages when we just had the GPT-3 or GPT 3.5 ChatGPT, it was just the next token predictor, right? So till the date it is trained, it has access to data only till that date, essentially. So if I suddenly if it was trained before till December 2024, and if I or maybe say December 2023, and if I ask it, who is the president of the US in 2025? How it is supposed to know? I mean, it's unreasonable to ask that question. And questions like, what are the flight times for a specific airline today if I'm planning a trip somewhere? So these are queries which would require access to the current knowledge. And I think we have always been searching them up on Google or any search engine of our choice. But now these models have access to it. So they can do much more than just searching for us. And I think an interesting application I find on a daily basis, because I use it for certain purposes too, is when I don't know exactly what I'm looking for. I just know maybe the key around that. Okay, I'm looking for a movie which had this reference. I have no idea as to how to search that. But I'm just throwing some keywords paraphrased as a question. And they're able to give me that. So I think those are some really interesting applications on a daily basis. But this is where one of the key focuses of agentic AI is that how can we support LLMs with other tools, essentially, which have been grounded in factuality, with correctness, which have some guarantees. And I think that's how I would like to define it.
Right. Siddhant, I'm just going to give this a little bit of more like a personhood kind of a thing, because, and would want your, opinion or thoughts on it, going forward, maybe in like another few years, we just starting the agentic AI frameworks, we've not totally developed, proper agentic AI platforms, which can do kind of, a lot of things. But going forward, I mean, you mentioned even the LLM modulo framework can add a little bit of planning to it. Do you think that with these multi agents adding multi agents to it, with these frameworks of like maybe planning, maybe reasoning, maybe acting, maybe more understanding, you mentioned about common sense, would that like kind of give it like some kind of autonomy, and would that kind of eventually kind of lead to maybe the models being able to generalize or even tackle questions which has been, like you said, outside of its training data, maybe not in the is something like that you think is possible in the next few years?
I think absolutely yes. There's no reason as to think why, since we have come all this way, where probably we wouldn't have thought, I think 5 years back, or maybe some people would have had that vision that maybe there should be a model which understands every possible thing in natural language that us humans can speak. So it might have been somebody's brainchild for sure. So yes, why not? Maybe these models will be able to perform exceptionally well at a bunch of tasks. And I think more than the performance, doing well at multiple tasks, I think these guarantees, the correctness, the verification abilities as to how do we provide some soundness guarantees. And I think these are concerns that have been there in computer science since day zero. Those are not some new problems that have come up naturally. They still exist when we are studying new algorithms. And I think even for a lot of frameworks, efficiency and correctness would be a great issue. For example, a lot of these proprietary models came under fire when they were spitting out words regarding certain biases which were not really ethical. And because there has been data and there is nothing we can do about that, because there is good data and there is bad data. As to a very good question to think is, why are models that are generating code so good at it? Because the code data is extremely clean in terms of correctness. What we have put on GitHub or maybe other sites as well, it may not be formatted well. It may not look very well to somebody who's like finds aesthetics of code really important, but it's correct. So there's a lot of correct data which tells you about how much the quality of data these models could have been trained on shows up when we are using them for a specific task. So I think these properties of, as I said earlier, about correctness and soundness are definitely way more important. I think we should try, first of all, achieving them. At least I would try, my efforts would be to getting these properties achieved for maybe a small set of tasks, see how generalizable those methods can be for several other tasks, rather than scoring. So the idea is, it's always the false positives that can cause you trouble. Because if you're saying, great, that this model is doing 90% at a specific benchmark, how critical are those remaining 10% points? Or how critical was it to provide the right reason to get to those 90% correct data points. I think those are questions that are way more important than, oh, let's just get 90% on 5 other benchmarks. So there is generalization across multiple problems, multiple domains that we may want to use these models and get this generalization. But then there is also the set of properties which may even want to achieve even for one specific problem and see how we can scale it up. So yeah.
Right. Siddhant, I mean, yeah, this AGI term, I mean, it's something, it's hard to define. And, when we talk about AGI, I mean, again, it goes into that thing that, people don't want to like, kind of talk about. So maybe let's not call it AGI. You spoke about like generalizable agents, agents which can, generalize out of their training data. What do you think, according to you, you've been invested in the space or maybe at the cutting edge of knowledge and people who are doing a cutting edge work, what do you think could be the approach of building these generalizable agent? Because you yourself have been researching and developing embodied AI, and people have kind of mentioned that maybe embodiment, and maybe it's understanding of its physical environment will kind of bring about these generalizable agent. And then there's Dr. Fei-Fei Lee, who's working on pretty much the same thing about like the spatial world. What are your thoughts, what are your intuition about this? And I mean, to develop this generalizable agent, what could be the approach? And maybe also talk about the embodied AI agents that you're talking about. And when you're talking about building these embodied AI agents, is it only the software stack that you're working on, or eventually you would like to partner with like an hardware company and kind of build these humanoid or bipedal robots? What's the plan?
So I may not have a very clear-cut answer as to what the right approach would be, but I think certain considerations that I do have in mind while thinking if I have to build an approach for generalizable agents, what those would be. And one of them would be, as I think we have discussed at length about, is understanding the failure points for sure, because that gives you a lot more insights as to where are these models breaking, essentially, not just for one task, but for many. There is this another thought experiment that comes to my mind based on your question, which is called the Mary's Room. And I think it was back from some 1980s or so, which essentially talks about that Mary is a very accomplished scientist who is put in a black and white room and has learned everything that is to learn about experiencing colors. So till the most granular aspect of what would be your hormonal changes or your sensory, how would your rods and cones interact when they see a specific color. So till the extent that science can explain, she has all the information. And the question here is that if she comes out of the room and sees color, is she going to experience something new? And this thought experiment, before I come with an answer, I mean, it's not like it can have two answers, but this was designed to oppose the view of physicalism, that everything that we see can be defined in terms of physicalism. And people who argue this say that yes, she will, because there is an experience for us humans that we may get something which is beyond understanding these physical senses, at least when we experience something new, which may be hard to code it up, maybe right for us, but maybe for a more smarter civilization, maybe yes, I'm not sure. But anyway, the point is, building these agents cannot just rely upon language for sure. Is not, or maybe not just images. So there is an extent to which we can reach by utilizing different modalities in which we collect information, in which we throw in information in all these models. And embodied agents can be the embodiment of these technologies that we are talking about. That let's bring in images, let's bring in the text that describes those images, let the robots understand and they are able to converse with the human, understand what the human wants, till the point process it in terms of images, and then come back with another natural language response, and the entire cycle can be done. It's a really, really hard problem, but it's definitely, at some point, it may become very useful. But there are definitely going to be tasks. So I'm limiting at least in my understanding, I limit the extent to which these models can be useful, specifically to tasks where we as humans experience those emotions that are hard to explicitly state in terms of expecting that we can get that from these models. I don't know if I should call it the sixth sense, but that experience of seeing that color maybe is really hard for these models to understand. So there will always be creative endeavors that only us humans will be good at. And I think we may be able to focus more on them once that these models are able to handle simple tasks, which has just been the cycle with every new technology. That as a civilization, I think we came up with wheels, we came up with more complex machines, and then we started shifting to problems which were earlier not known. If you ask somebody from 2 centuries back that do you ever see humans going to the moon? No, they never thought of it because there were much more important problems to deal with at the time. And I think that's what the cycle. I think that cycle keeps going on. Right now, we have problems with this. Once we get to a point where these models come with guarantees, are able to do a lot of menial tasks that maybe are not menial right now for us, which is again a subjective term, but may become then maybe we can focus on some other greater problems and advance and come up with newer technologies. So I think that's how I see it progressing. There are definitely going to be a lot of pitfalls. It's not a smooth curve, and it's not just uphill from here for sure. But those downfalls are really, really important in keeping a check as to what we are building, what we are going to do, how these models are going to interact with us. The idea that you pitch, I haven't thought about it, but it would be really, really satisfying to maybe see how I can at least be a part of a team which implements these models in an actual hardware robotic setting. I've had a very, very brief experience of working with real robots. And it is a hard endeavor, naturally, because there are way more problems in the real world that you would encounter than you would just do in simulations. Because again, those safety constraints come into the picture, right? In a simulator, you don't really care about what the robot is doing, what the arm is doing. In real life, it could be a matter of life and death. So, especially now with language being another modality added to embodied agents, we have all the more concerns to look at. So before it even goes to that extent, I think we should be able to, or we should ideally work towards getting these guarantees in just these language models, because the implications can be far-fetched once these get into the real world for sure.
Right. Siddhant, my last question to you. I mean, would you be able to share, according to your perspective, what do you think would be the most exciting developments of AI in the next 5 years, say, around 2030? And also leave us with your thoughts, your vision on what the world would look like. How would AI impact the world, the society, the good and the bad side,
Those are really, really deep questions, I think, but I'll try to answer them to the best of my knowledge. I think a lot can happen in the next 5 years, given a lot has happened in the last 2 years that way. We have come from people in AI looking at very different disciplines of their own interests, to people beyond computer science trying to look at what language models can do. I think the spectrum has completely changed. And the way I try to, it's not a prediction that I would like to make, or at least like a foresight, but the idea is that extrapolating what has happened given the previous context, maybe there are way more things that start impacting the way we see these technologies, I guess, and the kind of applications that we are still not aware that they may be able to work on, we may be able to use them very fruitfully. One of the things, at least I don't know what will happen, but I think an easier thing to answer for me would be, what I would like to see is having a very clean, objective understanding of what is really happening under the hood, which I think will speed up the progress of utilizing these models, or stopping their uses, all the more important in certain cases, really, really crucial. Not just from an academic research perspective, but also from an application perspective, which, as you had brought up, that it could have a ripple effect across several countries as well. So we don't know what exactly could happen, but I think that understanding can really, really help, even bridge the divide to some extent, if people are on the same page. And I think that's what research is essentially all about, that we continuously argue with our points until we come to a conclusion and that we agree upon. So that, I think that level of understanding with this technology is really, really important in the next 5 years. And I do firmly believe that we will get there at some point. The good and the bad, I think, I remember you pointing out, saying that there is a fear in the minds of a lot of people, at least, people who don't really understand, who are not even in the field at least, would understand what these models are doing or what they are not doing, even to the extent of people who are building it, for example. So the good and bad depends on how we utilize them for. I think I see good and bad in a very relative sense, in the fact that technologies are not, again, like, should not be personified that is it a good technology or is it bad. I think the use cases that we as humans define or give them make that distinction, which again goes back to the point of we can only do that once we understand them. It's really not easy to say that this may be a good application or not. And bad, I think, in my mind, I think of it in terms of safety, because human safety is foremost, irrespective of how the technology is being used. So I think that is a very, very critical path that needs to be adopted. And I think even if we are, even in the endeavors at a very small level that we are trying to understand these models, it is important to keep these considerations in mind, because we never know how a small design in a framework can really impact once it is deployed out there. And it's not the first time that models would behave unexpectedly in the real world. We have seen that even with models we were confident with. So this is all the more a riskier game. But the trade-off is big enough to invest into, because they can be really, really useful. They hold a lot of potential, but provided we are able to see clearly through them and know what they are good for and what not.
Right. Yeah. Siddhant, really, really appreciate you taking time and being part of the podcast. And you rightfully pointed out, I think, the world, the developers, the cutting edge, the leaders in the space who are developing this need to kind of, peek under the hood and should be able to kind of understand what these models are actually doing, and like you mentioned, I think, you're pushing out these models out in the open without truly kind of understanding its capability. The pros and cons are obviously, it can completely change a world. The healthcare can be completely redefined. The way we work can be completely redefined. But the other side is that it can also take away all of our jobs, because even right now, the tech stack itself is not, like you said, inherently good or bad, but its capabilities are so good that, right now with the automation bit, I think, like I mentioned earlier, we live in a top-down hierarchical capitalistic world, and every organization maximizes profit, and if as soon as they start realizing that, we humans, we the ones who work, we all work, don't our attendance is low, we get sick, and we take holidays and so on and so forth. These models, they don't have any of these comms. They can work 24 hours non-stop through the years, and the cost itself to the companies are going down, because we getting AI, which is more and more cheaper. So what would the world look like, if there is, we more and more jobs are getting automated? So I believe that I think we need to have more conversations, involve like the society, the common person, the government, academics, such as yourself, and these big tech companies, bring them together and have conversations, and it should be more decentralized rather than centralized. And I hope that, if we go towards that, and I think then with an explainable AI, I think we go into a future which is more beneficial for everyone rather than how the world currently is. Today, I think there is like possibly 100 billionaires who own possibly like 90% of the world. It's completely divided. I hope we don't go into that world which is completely divided with this tech stack. So thank you once again for taking time and being part of the podcast. And my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Thank you. Thank you, Siddhant. Really appreciate this. Thank you.
Thank you so much, Eddie.